Good morning. My name is Michal Kedziora. I would like to present our paper on blockchain decentralized voting for verified users with a focus on anonymity. The paper was made in Wroclaw University of Science and Technology in Poland. Here is agenda for our presentation. First, I will tell a few words about voting concepts, especially concerning its security issues. Then I will present current state of knowledge in this field, including related work in this.
Sorry, I had some problems, I think. I think I must okay. 1 second.
Because it looks great. I can go to the full view.
Yeah, but if I go to full view, do you see presentation?
I think you can go to the view and present full view, or it's in the bottom right corner.
Okay, let's
one, two, yeah, that one. Yep, exactly.
Okay. Here is agenda for our presentation. First, I will tell a few words about voting concepts, especially concerning its security issues. Then I will present current state of knowledge in this field, including related work in this area. Then I will introduce our e-voting scheme. We'll also present practical implementation we conducted during our research. I will finish with summary and future work. Let's introduce characteristics of e-voting, which is voting using electronic systems to aid casting and counting votes. Voting can be also described as an electronic system that allows a voter to record his or her secure and secret ballot electronically. Voting also means, in a broader sense, the use of electronic means in one of the following three processes. First is identification of voters. Second is casting the vote. Third is counting the vote. What we focus in internet voting, also known as online voting, which is often described as remote electronic voting, it describes the possibility to cast the vote over the internet. Such voting channels have been used in political elections in, for example, Estonia, Switzerland, or Norway. There are some common requirements for e-voting: eligibility and authentication, so only registered voters must be admitted; uniqueness, which means that no voter may cast his vote more than once; accuracy means voting systems should record the votes correctly; variability and authenticity, which is it should be possible to verify that all voters have been correctly accounted; and there should be reliable and verifiable authentic election records. Secrecy, so no one should be able to determine how many individuals voted. Non-coerciality, so voters should not be able to prove to others how they voted, otherwise vote stealing and coercion will be facilitated. And of course, minimum skill requirement for voter, minimal requirement for equipment, and minimal time required for one vote. In order to increase anonymity of users, many works introduced blockchain networks to the voting protocol. The authors of paper Voting with Blockchain and Voting Protocol with Decentralized and Voter Privacy proposed to use the blind signature protocol. In our research, we based on this solution while adding smart contracts. For the basics, the blockchain is a growing list of records called blocks that are linked using cryptography. Each block contains a cryptographic hash of a previous block, a timestamp, and transaction data. The process of mining a block in the network is carried out by performing the following sequence in an endless loop. Each node participating in the extraction of a block collects a list of publicly announced transactions awaiting approval, and according to the rules defined by it, selects those that can be introduced in a newly created block. Before attaching selected transactions to the block, they must be verified. It's checked whether the input data in the transaction has not already been used to protect against double spending. Before creating a block, first, the latest block of the longest chain in its existence. For example, the one that required most input for the calculation work. The result of the hash function, the found block, is appended to the header to the newly created block. When another work node finds proof of work for the block and broadcasts it on the network, each of our nodes verified the correctness of a transaction it contains and attends its copy to the blockchain. Blockchain struggles to be incorporated into registry. First, permissionless public blockchain was introduced, for example of Bitcoin and Ethereum. It turned out that the scalability of this kind of network is not sufficient. It's need hours to confirm a record was added to blockchain. There's a high cost of executing transactions. Security of public permissionless blockchain is insufficient, and malicious nodes in NT is known. There is immutability of transactions, a smart contracts deployment is immutable. Therefore, potential bugs cannot be fixed. Decentralization is questionable as networks becomes centralized between major wallets in use. And as for example, in Ethereum, there are a few mining pools which have majority of power in network. There are also many security issues with blockchain technology itself. Blockchain evolved lately into private networks, which is the only company running network has more or less control.
Excuse me, your slides are not changing.
It has much shorter transaction confirmation, reduced data render, but security
Your slides are not changing.
Okay, let me fix that. Let's jump here. Okay.
Yeah, thank you.
Slide. Okay. I think here. Let's try now. Okay, let's go to. So our voting scheme starts with voters list preparation. The organizer prepares a list of public keys of cryptocurrency wallets of users who will be entitled to participate in the vote. This is an activity that is not performed in the scheme, and the method of user verification depends on the organizer and the type of voting. The user list will be needed when verifying user blind ballot. Therefore, this process can be done until then. Second step is generating keys by organizer using RSA algorithm. Before the organizer starts voting, the public and private key must be generated. The keys will be used for digital signatures of ballot for the subsequent verification. Third step is vote creation. The organizer can create a vote by creating a list of voting options. Candidates are signed up a smart contract, which makes them visible to all users of both applications. Fourth step is sending a ballot for verification. The user selects an option to vote and votes. The ballot is then encrypted with a public key. The user receives a scrambled ballot and a blinding factor which will be needed later to decrypt the signed ballot. The next step is to send your ballot to the organizer. Fifth step is ballot verification. The organizer must verify if the user is allowed to vote, having access to a list of all sent encrypted ballots. For this purpose, it compares the addresses from which the ballot was sent with the addresses on the list of users that was created earlier. After possible verification, the ballot is signed by the organizer and sent back to the user. Sixth step is sending a ballot. The user, using a part of the public key and the blinding factor, can decrypt his ballot already signed by the organizer. The user then changes their wallet address. Thanks to that, the user remains anonymous after sending the ballot. Seventh step is result verification. The organizer has the opportunity to count the ballots and share the results. All verified ballots will be recorded on the QuestChain contract. In final step, the user has access to all verified and approved ballots. It can display the number of ballots cast for each voting option. In addition, he can search his ballot from the list of ballots taken into account in the election results. To do this, it searches for a ballot in terms of addresses from which it was send. The project consists of two separate applications dedicated to groups of users. First is voter, which is a person taking part in voting. The second is voting organizer, which is a person responsible for creating and conducting a vote. The contract has three implemented data structures. First is one ballot, a voter ballot that is created when an option is selected, and the ballot is sent for verification. Second one is signed ballot, so verified ballot of a voter. And the third is vote option, a vote option that is added by the voting organizer. To sum up, the solution is fully implemented by the proposed architecture and enable voting. However, in order to be able to implement this system, many improvements for users should be introduced. These improvements, possible fixes and changes are listed below, so many of them facilitates the use of the application for users or adapt the use of Ethereum transactions to reduce the requirement for the user man-in-the-middle attack who's analyzed for its impact and the attacked application's activity.